It's good afternoon. Thank you for joining me, and thank you to the organizers for the invitation, and Steve, I appreciate you also doing the discussion. I'm excited to be here and to get some good feedback. Some background on this project. This is one that I've been working on for quite a long time. I actually started working on it as a first-year PhD student, and 8 years later, I'm still working on it. So some of you may, in fact, have actually seen me presenting an earlier version of it, but it's really changed a lot in the last couple of years, and I'm just starting to present this new version. And so I'm especially looking forward to your thoughts and comments on this. Okay, so, over the past few decades, the phenomenon of offshoring has really caused a substantial shift in the geography of manufacturing, right? So this graph shows manufacturing as a percent of world output over time. And we can see, starting in the 70s and through the 80s, right, Japan starts to emerge as a manufacturing power, while the US and Europe, this is Germany here, Britain here, see kind of a decline, right? And then in the 90s and 2000s, of course, you see China's emergence as a major manufacturing power. That's here, while the shares of the other manufacturing powers decline. Now, of course, as you may know, there have been some shifts in this pattern in recent years, but China is still often thought of as the world's factory, and a lot of those big changes occurred during this time frame. Now, rising competition from Japan in the 80s led to warnings from policymakers and pundits in the US that offshoring manufacturing could really damage innovation. And in the past decade or so, these concerns have reemerged because of China's rapid growth and its path to a manufacturing power, alongside the US's decline in manufacturing and this general climate of doubt surrounding the benefits of globalization. And these concerns really haven't actually been limited to the US. Okay, so they've been mirrored in Japan and Taiwan and other places, of course, as well. Both these countries have seen an acceleration of production offshoring to China, even as they begin to lose kind of their previous dominance in 1980. And both countries have really grown increasingly worried that their innovative capabilities are being undermined. And this is something that I repeatedly heard myself when I was living in Taiwan, and is that there was a lot of concern that their innovative ability of their firms were being undermined by this offshoring shift. So what's the concern here? Why are they concerned, right? What is it about offshoring that might have anything to do with innovation? So there's a few different mechanisms described in the literature. So the first sort of predict a negative impact. Okay, so first is this idea that there's a close-knit relationship between manufacturing and R&D. And the idea here is that when you're developing an idea from a concept into a marketable product or process, it requires this continuous in-person collaboration with those manufacturing the goods, right? And if you introduce geographic distance, you're actually losing a lot of these tacit knowledge flows. And so this is hurting the innovative capacity of the firm. So in this particular theory, offshoring is actually diminishing the firm's ability to innovate, right? The second primary sort of theory underlying the idea that offshoring might harm innovation comes from Erica Fuchs and co-authors, who argue that it's really because it changes incentives. Okay, so she argues that the differing characteristics of production sites, so different wages, different materials, different organization of production in different countries, really changes what product development, what innovation is profitable for firms to pursue. And in particular, it can really reduce the incentive for firms to invest in cutting edge innovation. Just to illustrate this point, I've included a figure from her science piece where she highlights the example of high-end optoelectronic components for. She basically shows that when US firms shifted production to China, they abandoned production of the most advanced technology products. The firms that had offshored not only stopped producing in those advanced products, but they actually stopped innovation in the most advanced products. And the main reason was actually because producing in China increased the cost advantage of the old technology, right? So you can see if they'd kept producing in the US, this is kind of where the current or older technology would be. As soon as they move it to China, it's all the way down here, which makes it actually even more cost effective than investing in kind of newer high-gen innovation. And so the implication of this argument in this context is just that manufacturing offshoring can reduce innovation overall through a change in incentive. Okay, so this is an incentive as opposed to a capability story. And it can cause an incentive to actually shift from explorative to exploitative innovation, or from product to innovation. This is a that I'll be returning to a bit later. Now, on the other side, there's a theory in economics that might predict that offshoring would actually enhance innovation. Okay, and the reason it would do so is through efficiency gains, through reallocation of resources. And so this can operate through a partial equilibrium effect, right, where within the firm there's a reallocation of resources. So maybe that's cost savings to shift away from production towards R&D, or it could even be between different types of innovation. And then there's a potential general equilibrium effect, whereby the reallocation of resources is actually across firms and across industries. It could be seen in perhaps the entry of new innovative firms. We're really going to be focusing on the partial equilibrium effects, but I wanted to at least note that there is the potential for this general equilibrium effect as well. Now, given that there's some ambiguity in the theoretical literature, we might hope that the empirical literature would help resolve the nature of the relationship. But so far, that empirical evidence seems to be somewhat mixed, hampered both by a lack of appropriate data and also by just the endogeneity of both offshoring and innovation, right? It's hard to know which direction it goes, any effect goes in, right? And these are both kind of slow-moving, long-run changes. So teasing out any kind of relationship is really, really challenging. So there's some case studies that have shown evidence supporting a negative relationship, but they're really not identifying any clear causal relationship, and they're not looking within firms either. And there's some other papers that have examined the impact of import competition rather than offshoring on innovation, but that might operate through some very different So what we do in this paper is we advance our understanding of the impact of offshoring on innovation by going beyond previous empirical papers in 4 respects. And so first, we are identifying a causal relationship between offshoring and innovation. We're using a 2-stage least squares estimation strategy that exploits a policy shock in Taiwan that spurred a surge in offshoring to China for only some products. Second, most of our sample firms have a portfolio that spans multiple product categories. And what we're doing is we're using a very unique data source that actually allows us to observe both the offshoring of particular products and components within firms and link that to patents using this concordance, and so we can actually see the effect of offshoring specific products on the associated patents. We are distinguishing between product and process innovations, which allows us to observe the effect of the policy shock on the nature as well as the level of innovation. And we find kind of a series of empirical facts, which we interpret to support pieces of both sides of the theoretical argument. Right? We find evidence that offshoring changes firm incentives and can lead to a reduction in innovation. But we also find some evidence of a reallocation of innovative resources in support of standard techniques. So just to preview our results, we find kind of what we call a first order effect which is that offshoring has a negative impact on the level of innovation in offshore products. And in terms of the nature, this negative effect comes primarily from a reduction in product innovation and a shift towards innovation. And then what we call a second order effect, it seems to have a positive effect on the level of innovation, particularly product innovation, in other parts of the firm portfolio, and in particular, the other parts that are kind of the closest to the offshore product. So we interpret this set of results to support the theory shown in the beginning that offshoring actually changes incentives for this, right? So it creates this incentive for the firm to focus on cost reduction, process innovation abroad, while focusing on new product innovation at home. I'll be returning to this in a bit, but I do want to explain the setting and the context and the approach first. Okay, so as I mentioned already, our approach exploits this policy shock in Taiwan. This is kind of the critical part of our empirical strategy, and let me explain this in a little bit of detail. So the first thing to note is that Taiwanese companies are, important electronics and IT manufacturers, and this is the industry that we're focusing on. But prior to about 2000, FDI into mainland China was really heavily restricted. And the reason for that is because Taiwan was led by Li Denghui throughout the 90s. And so he was really worried about cross-strait economic relations because he was worried that unrestricted FDI would make Taiwan too dependent on the mainland. There's a host of political concerns he was worried about. And so he instituted this Yongren policy. Okay, and this placed really significant restrictions on investments by Taiwanese firms in mainland China, especially in electronics and IT. Now, to be clear, some Taiwanese firms did circumvent these restrictions to a limited degree through indirect investment via Hong Kong and other third countries, but they were taking a risk in doing so. And as I'll show you shortly, if you look at trade and investment flows during this time, it's pretty clear that these policies were a constraint on trade. Now, in 2000, Taiwan held its second ever direct election for president. This was its transition from authoritarian to democratic. And Li Denghui's designated successor was unexpectedly defeated by this guy, Chen Shui-bian. And he was the leader of a party that had never controlled the presidency of Taiwan. It was a brand new party. And he replaced his predecessor's restrictive FDI policy with this new 积极开放有效管理, or active opening and effective management policy in 2000. And what this did is it eliminated a number of the restrictions, but in particular for our purposes, it eliminated restrictions on 122 price types. Okay, now it was not a full liberalization. Many restrictions remained in place, but the effective cost of offshoring production to mainland China for those 122 products effectively fell. And so what we're doing is we're actually exploiting the differential cost of the policy on these different products in empirical design. Now, of course, right, for this strategy to be valid, we have to assume that the products impacted by the policy shock were not systematically more or less technologically dynamic. We're not on different kind of innovative trajectories than the ones that were affected. And we're not too worried about this for two reasons. One is that, of course, these categories were not picked randomly, but they were primarily concerned about national security when they issued this policy change. They were not necessarily motivated by selecting the least technologically sophisticated. Now, the one exception is the case of semiconductors. They actually did deliberately omit them because they were worried about keeping the most dynamic parts of the semiconductor industry in Taiwan. So we've actually excluded semiconductors from our regression. And the second reason that we're not too concerned about this is that if you actually look at the policy categories that were liberalized, which you can see kind of a summary of them in this table, it seems to be a mix of high tech and low, right? Not systematically lower or so you have this unexpected election outcome, right? This results in policy shifts that substantially reduce the cost of offshoring to China. And this policy affected some product categories far more than others. In response, many Taiwanese firms relocated their manufacturing for the global market from Taiwan to China. So Taiwanese firms tend to, their customers are kind of all over the world, right? Especially in the US. Rather than exporting their manufactured goods from Taiwan, they now start to use China as an export platform. Okay, so they manufacture goods at subsidiaries in China, and then they export those goods to the rest of the world. And it's well documented that this is kind of the way that they tended to use China, especially at the beginning, is as an export platform as opposed to trying to serve the same market. And this is how we're going to measure offshoring. Okay, so through exports from Taiwanese subsidiaries in mainland China. Of course, this is not a perfect measure, right? We can't measure offshoring to other non-China sites, and we can't capture offshoring that aims to capture sales to the Chinese market. But as I noted, it is well documented that most of Taiwanese offshoring was to China, and that Taiwan primarily used China as an export base, especially in the early 2000s. And our data seem to support the idea that this 2001 policy really did change trade flows between the two and offshoring. So the graph on the left is constructed from our data, and it shows that exports from Taiwanese subsidiaries in China did surge in the aftermath of the policy shock, and especially that this is especially true in those categories that were previously banned, right? So that's this red line here. These were previously banned. You see this big spike. In the ones that continued to be prohibited, you do not see that. Now, one shortcoming of our data is we only have one pre-policy year, but this graph on the right, which uses official Taiwan government statistics, shows kind of a similar surge in trade with this very clear demarcation. Then this leads us, to our ultimate question: how did this affect innovation, which we measure as business? Okay. Now, the data that we pulled together is one of the most important contributions of the project. And it's especially useful because it allows us to look at the effect on innovation within firms. Okay. This diagram is illustrating these different data sets that we used and how they're all linked together. And so let me just briefly walk through these different components. So we start out identifying publicly listed parent firms in the electronics category. Okay. We then link them to their subsidiaries in China, and then identify all exports that emerged from those subsidiaries in China using Chinese customs data. Okay, so again, this is our proxy for offshoring, right? The big downside of these data are that starts in 2000. There does not seem to exist Chinese customs data prior to this point, but it records export value, price, quantity, et cetera, at HS 6-digit level. And the primary variable that we use is export value. So we then identify all USPTO patents taken out by those firms. And the reason we're using USPTO instead of Taiwanese patent data is because these are exporters. They're very dependent on foreign markets, especially US markets. And Taiwanese firms tend to patent their most important inventions in the US. If you actually look at a per capita basis, Taiwanese inventors own more US patents than inventors anywhere else. Of course, patents are an imperfect measure of innovation, but because we are interested in this, partial equilibrium within firm effect, there's really no other obvious way that we could measure innovation at a firm and product level. And now the most challenging and most important part of this matching is actually connecting the patent and the customs data. So patent data classified using IPC codes, while customs data is classified using HS codes. And these are trying to do very different things, right? So IPC is trying to identify the novel technical features of the invention. HS system is trying to disaggregate goods into economically meaningful stuff, right? And so it means that constructing a concordance is really hard. And the reason we were able to do this is my co-author, Nick Dolas, has this new machine learning and text matching algorithm that allows us to construct this match at the firm and product. And just to give you an example of what this looks like, okay, so this is an IPC4 category, G08B, signaling or calling systems, alarm systems, right? And these are all of the HS6 categories that it seems to match to according to that algorithm, right? So only very rarely does it provide a one-to-one mapping, which actually is an advantage of the approach. And it assigns a probability to each of the mapping, which in this case range from 0.03 to 0.7. And when we map the two, we multiply our patent counts by these. Okay, so we end up with 483 Taiwanese firms who either export or patent. We end up with 16 product categories, which we've aggregated up to in order to reduce sparseness. We have 11 years, and each observation is at the year, product, class, and firm level. Okay, so onto the actual regression model. So our base model is a long differencing specification. Okay, so it's taking each difference at the product firm level between a post-policy year, so 2003 through 2011, and a pre-policy year, which is 2000. Okay, we're using this long differencing model because it allows us to difference out our firm and product mix effects without imposing a lag structure, and because we only have one pre-policy year. Okay. So on the left-hand side, right, we have this patent count, right? And on the right-hand side, our key variable of interest is the offshoring value. Okay. And so basically what we're interested in is what happens to patenting in a product cluster for a given firm when that cluster gets okay. And both of these are logged, so you can interpret coefficients as elasticity. Okay, so if we look at just the OLS results, right, we're seeing this positive and statistically significant, right, elasticities ranging from about 0.003 to 0.008. However, we worry that our OLS results are biased, right? So maybe they're biased by something like a time varying demand shock that affects both offshoring and patenting at the same time. So as an example, maybe a Taiwanese firm expects a future increase in demand for a certain type of product. And so it might shift production to China in order to meet that growing demand and also patent more in order to take advantage of this market. Okay, so this would lead to an upward bias. So to address this, we use a two-stage least squares strategy that exploits the policy shock that I just described. Okay. And in particular, we're exploiting this source of product variation within firm product variation. Different products were affected differentially by the policy shock. And so this instrument is just a simple indicator variable where the 122 affected products are equal to 1 and the other products are equal to 0. Okay. And this is the formal two-stage least squares equations. So first, we're regressing our offshored value on this graded indicator variable, right, where these 122 previously prohibited products are assigned a value of 1 and 0 otherwise. And then in the second stage, we're using the predicted exports from stage 1 and regressing patterns on that. Okay, and it's all still long differences, it's all still a lot. What we find is actually a sign flip. Okay, so now offshoring seems to have a negative and statistically significant effect on patenting, with elasticities ranging from -0.2 to -0.3. And as before, the dependent variable is the log change in patenting, the independent variable is the log change in offshoring value. And so this, confirms our suspicion of there being an upward. Now, one concern with using OLS, right, is that our data are quite sparse, right? Count data models tend to do a better job of dealing with data that have a lot of zeros, right? And so we use the IV plus on model as a robustness check. We changed the specification slightly because it can't handle negative values. And so we moved the base patent here that used to be on the left-hand side to the right-hand side. Okay. Now, another advantage of this model is that you worry less about the logs of x plus 1 specification that leads. But luckily, it seems to be quite robust to this alternative specification, so seeing these negative. And rather than boring you by showing a lot of robustness tables, especially since I have limited time, I thought I'd just provide a list of some of them. And I'm happy to return to any of these later if you're interested. So it's robust to including a pre-trend control, both at the global level and at the Taiwan level. Citation weighted results maybe get a little bit stronger, suggesting that it's not just marginal innovations that are being impacted. Foxconn is a bit of an outlier, so we try excluding them. We use the inverse hyperbolic sign instead of logs, and we've also tried further restricting the sample to firms that are short in patent, and it seems to be quite robust too. Now we follow the same approach to examine the impact of offshoring on the nature of patenting, right? So we found this impact on the level of patenting, and now we're interested in what's happening to the nature. And we use this new process product patent classification from Gingelmeyer and Robinson. They were kind enough to share this with us. And basically, what we're going to do is we're going to, rather than having the dependent variable be the count of all patents, we're going to look at the count of process patents, the count of product patents. So this is the same two-stage least squares specification. Just to fit it on the slide, I've only kind of reported the most, the coefficient of interest, right? And what you can see here is that it appears that most of the negative effect was really concentrated in this product innovation, right? So this is where you're seeing the negative effect. And in process patents, you're seeing, no or maybe slightly positive effect. Okay, so innovation in the categories that were offshored shifted towards process innovation and away from product. Right, so how do we interpret this, right? So why would offshoring cause a drop in innovation and a shift towards process innovation? So if you think back to the beginning when we were talking about how offshoring may change firm incentives, that may help us understand these. So in our context, yeah.
Sorry if I interrupt you, there is a clarifying question.
Okay, yep.
Yeah, Rafael Martins asks whether, he said, what is the set of still banned products used as a control sample? Does it include every single product not included in the policy, or is it a particular subset of them?
So it's all of the unaffected product categories, but it's only by electronics IT firms, right? So it's other products in their category, in their portfolio that were not affected by this policy change.
Okay, thanks.
Okay, great. Okay, so one way that we might think about these results is as follows. Okay, so our Taiwanese firms are offering their customers a set of products. Each of them represents this trade-off between price and performance. They can sell more by lowering the cost or enhancing the performance, or both, right? And typically, we think of process innovation as really being focused on reducing cost, and product innovation as being focused on kind of enhancing performance, right? And so when firms are able to offshore production to a location with much lower factor costs, this shifts the trade-off that they face between competing on quality, product innovation, and competing on price. If you'll just bear with me briefly, let me kind of illustrate this in another way that might be intuitive to some of you. So in this figure, you have this blue isoquant here, which displays the combinations of quality performance on the y-axis, product innovation, and price discounts favored by customers on the x-axis, process. This blue line here, the slope represents kind of the relative cost of process versus product innovation, and prior to offshoring, the optimal combination is here. Okay. Now, when the policy shock allows offshoring to China for some categories, the relative cost of process versus product innovation shifts, and it's now illustrated by the slope of this line. Okay, so the new optimum moves to 0.2. Right. Why? Because the shift to a lower cost location allows a given amount of process innovation to deliver an even greater decline. Right? You're maximizing the benefits of low cost labor through process innovation. And so you can see the response is to decrease the amount of product innovation, increase the amount of process innovation, but this decrease is larger, which is why we see kind of this overall negative. Right? So, offshoring is basically shifting this trade-off, right? It increases the relative attractiveness of investing in process innovation at the expense of more investment in product innovation, right? They're kind of doubling down on competing on price in the categories that are allowed to offshore to take advantage of these lower. So just to summarize these first order effects, right? Offshoring reduces the innovation levels in the categories that are offshore, and that negative effect seems to be concentrated in processes, right? So they're reorienting towards process innovation, towards competing on price in these offshore categories. And so they're maximizing the benefits of offshoring and low-cost labor through more. Okay, so as the final piece of our story, what happens to the other parts of the portfolio? We find some evidence that firms actually increase product innovation in other parts of their portfolio, right? This we call a second order effect. And the idea here is that, there were some engineers, for example, who were doing product innovation in the offshore categories, and now they're not needed there, okay? So they're going to be reallocated to other product categories that are technologically proximate. You can think of this as kind of similar to the stranded asset theory of metal. And the reason why we're focusing especially on this technological proximity piece of it is because of the specialized nature of technology, right? So you want to utilize these engineers kind of in the best way. So to test this, same empirical approach once again, new dependent variable. Now it's the count of patents that are technologically proximate to those in the offshore product. Right? So the idea here, right, is that a firm, after offshoring some categories, switches its innovative focus and resources to closely related product categories. You might expect this small positive. So they're smaller than the first order effects, right? These are definitely smaller, but it seems to suggest that there may have been some reallocation. And if you look closer at the type of innovation, again, at this nature of innovation, then it does seem to occur in this product innovation category, right? So the cross-category reallocation is towards product innovation. And this is kind of consistent with the theory that I just stated, right? So these reallocated engineers were focused on product innovation before, makes sense that they'd be similarly engaged. So I know this is complicated. There's a lot of pieces going on. So let me try and kind of summarize it in a way that helps pull it all together. Okay. So our results reveal this somewhat complicated but interesting pattern, right, of the impact of offshoring production on innovation. So it reduces innovation levels in the categories that are offshored. That negative effect is really concentrated in product innovation, and they're reorienting towards product innovation. There's some evidence of a second order positive effect on product innovation in other parts of the firm's portfolio that are not offshore. And these results are consistent with this idea that offshoring might be a way for firms to deal with this tension between product and process. At home, they are doing more exploration of new product innovation, and abroad, they're maximizing these benefits of low factor costs, low cost labor through innovation. Right? So double down on competing on price abroad, double down on innovation. So, the high level takeaways, offshoring, particularly to a low cost country, does appear to have a negative effect on innovation levels. This seems to be less about undermining the innovative capability of the firm, more about a change in firm incentives regarding the nature of innovation. And we argue that basically what happens here is that there are these new offshoring possibilities that are available, that become available to Taiwanese firms. And it shifts this trade-off that they're facing between competing on new product technologies versus competing. Thank you very much. And I'm looking